This is a talk that I gave at the ASHS annual conference in Chicago, Illinois. My name is Lillian Pride, and I am a PhD graduate assistant under Shinsuke Agihara at the Gulf Coast Research and Education Center for the University of Florida. This presentation is about planting hole application of controlled release fertilizer and how it can reduce nitrogen use without yield loss in strawberries grown in the subtropical sandy soil. This is a strawberry bed. Conventional fertilization for strawberries is typically via fertigation. First, for 8 to 14 days, water is applied on the top of the canopy of the strawberry transplants, and directly after that, 2.2 kilograms per hectare per day of nitrogen is applied via fertigation for around 21 days, resulting in 47 kilograms of nitrogen per hectare. After that, a much less concentrated rate of 1.1 kilograms per hectare per day is applied, roughly 130 kilograms of nitrogen per hectare for the rest of the season. A lot of that fertilizer that's applied is actually lost to the environment before the strawberry plants can ever uptake it, especially during establishment. As you can see, strawberry transplants that are bare root are exposed and therefore desiccated upon arrival. That's why the establishment rate, the concentration is actually much higher than for the rest of the season, because these plants can only take up just a tiny bit of water, and that tiny bit of water that they can uptake needs to be full of nutrients so that these plants can establish. However, because the soil is sandy, the water with all the nutrients that goes into the rest of the bed quickly slips into the soil profile, especially with subsequent waterings, which actually pull the water down pretty quickly for the nitrogen, which is a soluble nutrient. Now you can actually take controlled release fertilizer and put it directly into the planting hole instead of using fertigation at all. The benefit of this is that it puts the nitrogen directly where it's needed. The polymer coating on the controlled release fertilizer resists leaching, and then this also results in less environmental nitrogen losses in both cases, both because the fertilizer is placed locally where the plant can take it up right after it's released, and also because the polymer coating resists leaching. Therefore, the objective of this experiment was to examine the efficacy of planting hole application of controlled release fertilizer as a new fertilization strategy to replace the conventional fertigation during establishment. We had 2 years of data for this experiment. We used Brilliant Strawberry, which is a popular cultivar in Florida. Of course, our soils are sandy. We have 97% sand in West Central Florida. We used a randomized complete block design. We used urea ammonium nitrate for our nitrogen treatments, just so that we were only varying the nitrogen and not any of the other nutrients that are applied via fertigation. For the first year, we used 4 rates. For the second year, we used 5 rates. And then for the controlled release fertilizer, we used 7 rates so that we could do some regression analysis. For the sake of this experiment, or this presentation, the data that we are going to present is going to be canopy projected area, which is a yield metric, or it's a growth metric, then yield, and then tissue analysis. For the statistical analysis, we did analysis of variance and model fitting analysis. So for the analysis of variance, we analyzed all treatments, and we used Statistical software, and we used the Glimix procedure. For the model fitting analysis, we did controlled release fertilizer treatments. We used sigma plot, and for the models fitted, we did linear, quadratic, exponential plateau, exponential decay, and sigmoidal. And then we compared them to see which one fit the best. These are our nitrogen treatments. As you can see from the bottom row, the potential savings range from 0 to 47 kilograms of nitrogen per hectare depending upon the treatment. Now, we mentioned the canopy projected area being a growth metric. What we do for that is we take an image and then we scale it based on the width of the bed. And then we pass it through image J, and then with the black and white, we take the area of the green leaves using color spectrum analysis. An example of this, say we look at 27 days after transplant. It might be 11.8 kilograms of nitrogen per hectare of controlled release fertilizer being 40% greater than the control. This is the 11.8 kilograms of nitrogen per hectare. This is the control. As you can see, even visually, you can compare those, which is pretty nice for the sake of presentations. But then also objectively, you can measure the area of the leaves this way as well. This is the statistical analysis of that same example. It's from the first year during establishment, and this is also a statistically significant difference. So during the first year, the 11.8 kilograms of nitrogen per hectare controlled release fertilizer was 40% greater than the 47% kilograms, well, greater than the control. So what this means is that the 11.8 kilograms of nitrogen per hectare controlled release fertilizer actually improved the growth of the plants during the establishment period. Now suppose we look at marketable yields for the first year. Let's look at November and February, since these are the months that had statistically significant differences. In November, 11.8 and 47 kilograms of nitrogen per hectare controlled release fertilizer resulted in 108 and 106% increase compared to the control. In February, the 47 kilograms of nitrogen per hectare controlled release fertilizer resulted in a 24% increase compared to the control. As you can see, I put these both on the same scale. The volume of strawberries that were produced in November is way less than the volume of strawberries that were produced in February. However, the strawberries that are produced in November and December are produced during Thanksgiving and Christmas, and this is actually a premium time for strawberries. And so even though the volume is so much less, this is a very important time for the yield to be greater for the grower, because they can sell their strawberries for just so much more. But that being said, it also doesn't hurt that the controlled release fertilizer resulted in yield increases also in February. The other differences we found using the analysis of variance were not significant, like with the controlled release fertilizer compared to the control. And that's actually great, because equal to better is what you're looking for when you're looking for a treatment to replace the mainstream practice. So in this case, it looks like we can actually have savings in nitrogen while maintaining and even improving growth metrics and yield. Now moving on to the model fitting analysis. Model fitting analysis for controlled release fertilizer for the canopy projected area during establishment for the first year resulted in a linear trend. So as the fertilizer rate increased, the canopy area, projected area also increased. In the second year, we had a quadratic trend. And so fertilizer rates, as they increased to around 35.3 kilograms of nitrogen per hectare, the canopy projected area also increased. And then after that, it declined. For the model fitting analysis for the controlled release fertilizer for marketable yields, similar trends for year 1, year 2. For the first year, we see linear increases. So as the fertilizer rate increased, so too to the marketable yield. We saw that for all months except for December, and also for the total of the season, as you can see. In the second year, we saw a quadratic trend, but only in December. So none of the other months, not the total season, only December had a statistically significant trend that could be reported. And as you can see, as the fertilizer rate increased, so too did marketable yield up to 23.5 kilograms of nitrogen per hectare, and then the marketable yields declined. For the model fitting analysis for the controlled release fertilizer for the tissue analysis, which we take at the end of the season for this example, in the first year, we saw a linear increase. So as fertilizer rates increased, so too did nitrogen uptake for the leaves and the stems. In the second year, as the fertilizer rates increased, so too did the nitrogen uptake for the whole plant. What does this all mean? Ultimately, what we concluded from all of this was that 11.8 to 23.5 kilograms of nitrogen per hectare is the best controlled release fertilizer rate for optimizing yield, saving 23.5 to 35.3 kilograms of nitrogen per hectare. And these results suggest overall that small amounts of controlled release fertilizer applied in the planting holes can replace nitrogen fertigation during establishment. In way of discussion, the strawberry bare root response to polymer-coated controlled release fertilizer may vary by year. We're thinking that it might be because of temperature, because the first year was consistently hot, and the second year was hot sometimes, but also overall pretty cold. And so this is actually significant because, well, it's not uncommon for one year to be hot and another year to be cold. And so what we found was that in both of these very common situations, the controlled release fertilizer resulted in equal or better growth at mid-range. So those 11.8 to 23.5 kilograms of nitrogen per hectare rates in both circumstances were positive or equal to the control. This study also indicates that it might be worth looking into other treatments in the planting hole for improving or maintaining yields. So we might be looking at fungicides next, maybe growth promoters, those sorts of things. And finally, you might have heard maybe a few sounds from this little guy in the background while I was doing this presentation. I actually had a baby this last year, and that's relevant because I want you to know, yes, you can do it all. You can get a PhD, you can have a baby if you have a wonderful team like this. I'd like to acknowledge my research professor, Dr. Agihara, for being just world-class, the best scientific support for my study, but then also very supportive of me having my baby. And also I would like to thank the students and the lab members in the same way, just world-class, amazing field and research team members, and just the very best and very supportive people for my life continuing as it has with my little baby. If science was a song, this is the band. And finally, I would also like to thank you for your attention.